Welcome back to Smith Coding and Design. So today we are going to go over this very simple part I have on the screen. It's not so much a tutorial as it is just showing some bloopers or some crashes I had while making this part. It's one of the simplest parts I've made. All it is an adapter plate that allows a gaming joystick to attach to the plate, and then some M6 screws go underneath of the plate and then bolt down the joystick, and then the slot here at the edge allows the plate to be attached to some 20mm series aluminum extrusions that can then either be attached to a gaming desk or to a gaming chair. So one of the challenging parts with this project in particular was that I'm using pretty much the entire X and Y envelope of the Tormach just to hold the aluminum plate. So I was using a piece of aluminum plate that's 12 inches by 12 inches and 190 thousandths thick, and that would essentially allow me to go ahead and mill out one plate and then just turn the entire piece, I guess 180 degrees, and then go ahead and use this empty side over here to create another, so I could get two parts out of one piece of plate. Again, the hard part was it's 12 inches by 12 inches, so really the plate itself was taking up almost all of the work area envelope of the 770. So what I ended up doing is taking an approach that I used to use a lot when I had CNC router. Used to have an Avid. I got rid of it because I hated Mach 4. So for work holding, what I did is I took the plate and I used double-sided tape and adhered the plate to a piece of MDF, and then used toe clamps to hold the MDF down and keep the plate nice and flat, and that allowed me to go ahead and make these parts. Ran into various issues with that, and we'll discuss those in a minute, but for now we'll go ahead and just briefly walk our way through the cam. It's very simple. So we have a pocketing operation where we just go ahead and then make our holes to mount our joystick, and then go ahead and mill out the slot to attach to our aluminum extrusions. We then just go ahead and chamfer. So we're just using a 1/4 inch chamfer mill here to break the edges, make sure there's nothing sharp. And then finally we use a 1/4 inch end mill, and we just do a 2D contour. I'm not using tabs because, again, the double-sided sticky tape is holding the part down. No need for tabs. So we just go through and mill out the entire contour on the outside of the part, and then that allowed me to pry the part up with a simple flat screwdriver, and then I was finished. So that's it for the cam side of things. Again, the hardest part was really just the work holding itself, and so we'll go into that next. Alright, so for this flat material, the way that I'm holding it is with some carpet tape attached to a piece of MDF, and what I will do is I will put this against some dowel pins in the Tormach using the Saunders fixture plate, and then I will use some Techco toe clamps to hold the MDF in place, and that will give me a nice easy way to hold this flat piece of aluminum plate. It's 190 thousandths thick without needing a vacuum table. And so this takes me back to my CNC router days. I used to hold a lot of flat material like this, acrylics, plastics, aluminum plate. So that's what we're going to be trying in the Tormach. Alright, so here we are at the machine. I have my 190 thousandths aluminum plate taped with carpet tape to a piece of MDF, and then I'm just using the precision dowel pins that come with the Saunders fixtures so that I have a nice straight edge here. And then here we go, I'm just using some toe clamps to push the MDF up against the precision dowel pins, and that will give me a nice firm work holding method for cutting this plate, you know, especially when it's so large that I can't use a vise. I don't have a vacuum fixture to hold it. This takes me again back to my CNC routing days when I used to own an Avid, and I would use carpet tape to hold down aluminum and other materials. So I hope that helps. Alright, so now we get into the first issue. I'm using a 1/8 Char's end mill just to try to contour around the entire part and cut it out. And unfortunately my end mill didn't hold up, and here in a second you'll see it shatter. There we go, so it broke, and that was the end of my end mill. Later I did decide to go ahead and use a 1/4 inch end mill instead, just to make sure that I would not break an end mill, and that led to more problems, which we'll see in the next clip. Alright, so now we get into the second issue. This time I'm using a 1/4 inch end mill, and again I'm doing the contour around the outside of the part just to cut it out of the stock, and I'm going way too fast for this work holding method. I'm going 60 inches per minute, and as you'll see here in a minute, I don't have dowel pins in the Y direction, only in the X. In this case, actually I have my 4th axis on, so it's butted up against the 4th axis plate. So without anything keeping the part from shifting in the Y direction, you'll notice by going 60 inches per minute, I actually move the workpiece, which causes chip welding. I ruin my end mill and I ruin my piece of stock, so I was not having a good day in terms of making this part. And what you're not hearing is the cursing that is taking place on the other side of the camera. Alright guys, here's the final crash, and this is just stupidity on my behalf. So after the crash in the previous clip, I just rotated the fixture 180 degrees and then went to town trying to make a part again. I didn't realize that when I crashed and I moved the entire fixture forward, I actually caused some of the tape to give out, and as you'll see here in a minute, the entire workpiece sort of pulls off the MDF, and I believe that was because, again, all the force in the Y direction when I crashed in the previous clip just caused some of the tape to lose adherence and it wasn't secure. Hindsight, I should have removed the piece of stock, put some fresh tape down, or at least pressed down on the top again to make everything was still adhered. I didn't do that, and it resulted in a crash that could have been avoided. I think in the future I might add screws to the 4 corners of the plate just to make sure that it can never lift up. I haven't had issues with double tape giving away before. That was sort of the first time. Another thing to note is in the future I would like to try vacuum work holding, particularly with a Pearson pallet or a Pearson vacuum fixture, and I think that will be a better workflow than using the double-sided tape. But when you're just trying to make a couple parts, you use what you have available. Anyway, I hope you learned from my mistakes and maybe had some entertainment from watching me fail. I'll catch you guys in the next video. Thanks for tuning in.